Good morning all. Welcome to the course EET 306 Power Electronics, which is based on 2019 scheme for KTU students. So this will be our first lecture and this will be an introductory section where I will be introducing to you to the syllabus as well as what all things we are learning in this subject. And parallelly in this semester itself, you have the laboratory experiments also, lab also you have. So it is better like you study the theory and then learn the practical things also. Okay, and basically the textbook that we are following is PS Bimbra and MH Rashid. Both these texts you can follow. So my lectures will be based on these two textbooks, and in your syllabus also these two textbooks are preferred. Okay, now let's move into the subject. So basically the syllabus is like this. We have 5 modules. As you know, 2019 scheme, you have 5 modules and the examination will be of 100 marks. So 70 marks will be. Part B will be 70 marks and part A will be 30 marks and 10 into 3 equal to 30 and 14 into 5 you have 70 marks, right? So this can be a division also. Okay, so examination pattern and all, it's familiar to you. Now coming to module 1. So module 1 you will be studying like what is power electronics, why you are studying power electronics, what is a power diode, what is a power MOSFET, then basically what is an SCR, that is silicon controlled rectifier, all these things. That's the basic. So I'm not going to explain the syllabus here itself. So, but by the end of this introductory section, you will be understanding what exactly you are studying in the 5 modules. So it's a step-by-step process. So let's see. So power electronics, the term might be familiar for you. Like the terms differently might be familiar for you. You have studied power system, so you know what is power, and you have studied analog electronics also. Last semester, the semester before, you have studied this. So what do you mean by power electronics together? So you know, when you studied power system, you might have seen that in power system, we are talking about high value of power. So power system or power actually talks about high power value. And normally we were concerned with the efficiency, right? So when we are transmitting a power to the transmission line, we are concerned with the efficiency. We are concerned with the efficiency of power transmitted. So in that is power system, so high power. And in analog electronics, if you remember, you might have studied about low voltages only, like low power application, and power here it is, there it was high power application, and here it was low power application, and efficiency is not a major concern. So efficiency is not a major concern. And so what exactly what is done in electronics? A transmitted power from source to load with minimum possible distortion. So concerned about, so you can write down the lecture notes also, concerned about transmitting power from source to load with minimum distortion. So power electronics basically is a combination of both, like how we are using the electronic applications for power transfer. So power electronics is a subject that concerns the application of electronic principles in power engineering. So together, so what all you have studied, so it is now we are introducing to you a new subject that is combination of both, power electronics. Okay, hope you understood. So basically to study power electronics, there are some basics required. So you should have an idea about basic electrical engineering. Basic electrical knowledge is required. Don't worry, we will be discussing everything here, even if you don't have the basics. Then analog electronics. So you should know what is a transistor, what is BJT, what is the active region, saturation point, all these things you should have a basic idea. Still, we will discuss everything. Then basically about the machines, and power system. Like that doesn't mean that if you don't know this subject, you cannot study power electronics. Some basics only. So you should remember when I say a synchronous machine or DC machine, you should know what is a DC machine. Like that basic knowledge you should have. So basically, this is what power electronics is. Okay, let's see. So what all I have explained, I have just given here in my PPT. So electronics engineering deals with distortionless production, transmission and reception of data and signals of very power of order of few milliwatts without much consideration of efficiency. So it's a very low voltage, low power application. Whereas in power engineering, it is mainly concerned with generation, transmission, distribution, and utilization of power at high efficiency. We normally calculate how efficient was the power when we transmitted it from sending end to receiving end. So all these things you might have studied in your S5 power system, power generation and protection, that syllabus you might have studied all things. And power electronics is concerned with the application of electronic principles in power engineering. Okay, so you got a basically you got an idea what it is actually, right? So now we will see in detail. So one example you can say of like electronic transmission. One example you can say, so if you have a mic here, and that mic we will give to the amplifier. So this is a mic here, and this will be an amplifier. And from the amplifier, it goes to the speaker. So this is a very low power transmission. Like what we are concerned is without any distortion. If someone is speaking here, someone is speaking through the mic, and without any distortion, all that we have transmitted should be amplified and given to the speaker. So that is what electronics is mainly concerned. Okay, so now here we are talking about power electronics. So basically what we do to convert, that is to process and control the flow. So basically we can define to process and control the flow of electric power by supplying voltages and current in a form that is optimally suited for the user loads. We have an input, we give that to a power electronic system. Look, I'm introducing a new word, power electronic converter. So we give that to a converter and we make it ready in the form that is required for the user. Like we make it ready for the user. So this power processor can be called as a power electronic converter. So you might be asking, what is a converter? You will study what is a converter going ahead. So here you just understand we have a power electronic converter. So input was there. So input can be an AC or DC, right? So input source, it can be AC or it can be DC. And then it will be having a voltage and the current will be there. And that will be, and a frequency, of course, a frequency also will be there. And that will be given to a power processor. So power is being processed or power is being converted. Some process is happening. So that is a power electronic converter. And from that, we are getting another value of voltage. Maybe we are stepping up or maybe we are stepping down. We don't know what we are doing. Based on the converter, based on the power electronic equipment, we will get an output. And this will be the frequency. So this will be AC or DC. So if it is DC, there is no frequency. Then load, then it will be given to the load, right? So, and you can see that there is a feedback. So something is being fed back and given to a controller, which the controller in turn is controlling the power electronic converter or the power processor. So we are giving an input and it is going passing through a converter and we are getting an output, and that output, some part of that output is being fed back and given to the controller. So like something is being given back to the controller and something is coming as and something we have kept as a reference, right? So we are comparing. So like if it is coming as 5 volt and we have kept the reference as 10 volt. So 5 volt is coming and the reference was 10 volt, and then that difference or the error, that the error happening is given to the controller, and that controller is in turn again controlling the power electronic converter. So I will give you a very good example, something which we are all familiar about. You're studying power electronics for the first time. So basically what is happening, one example I will give. Take the case of a charging mobile battery. So consider the case of a mobile battery. So what actually is being done? So you know the charger, AC supply will be there. So mobile battery, the input will be basically, it will be AC. Input is AC, and that AC is being converted to DC. And nowadays, you know, we have fast charging, right? So we have fast charging. So what exactly is happening? The voltage is being sensed. The voltage of the battery is being sensed, and that is given as a feedback, and error is calculated. So we have kept a reference, and what we are getting is different, then that is an error. Like the voltage of the battery is sensed, and that is being compared with the reference value. The error is calculated, and that error is given to the power converter circuit. Like what happens is, voltage of battery is calculated and kept as a reference, and voltage and output voltage is fed back and given to controller. So the controller, so what is being, so the error is being given to the controller, and then that error is being given to the power converter. So this is what actually happens. Like we have a set voltage, and the voltage that is being fed back, it is given to the converter, and in that way the process will continue. So basically, input power and output power is the building block. Then power processor, as I told you, power processor is the power electronic converter itself. Then we have the controller that is converting the, so from the controller only we are getting the error signal. So 5 volt was coming, so there's an error of 5 volt, and that is being fed back to the power converter. Based on that, the power converter is doing the conversion, maybe AC to DC or DC to AC, whatever happens, becomes upon, depending upon what type of the converter it is. Right? So this, I think this explains the things a bit more. The same thing, like we have the input source, AC or DC, or it can be unregulated. So there will be a power electronic converter, then the output will be there. And output is again fed back. And this is the reference. You can show on both sides. So based on the reference, we are again getting the error signal. And based on the error signal, we are operating the power electronic converter. So this type of circuits you will study in your control system also. Basically, I think in your signals and systems, you have studied a bit of control system. So maybe you have studied what is positive feedback, negative feedback, what is a closed loop. So this is a closed loop, right? Yeah. So this is basically the power electronic converter. That is the heart of power, a power electronic system. So heart of a power electronic system is the converters. So different types of converters now we will learn. Like before going into the subject, I want to discuss about why we are studying, like this is an introductory section. So why we are studying power electronics. So we know that we need to reduce the dependence on fossil fuels, and more renewable energy is being used these days. Then, so energy saving can be done by using power electronic applications. Like we have a variable speed compressor, air conditioning system, then lightning using electronic ballast. So cooling efficiency can be improved. So to improve the energy scenario, to have a better utilization of renewable energy resources, power electronic converters are very important. So that is one issue, like why we need to study power electronics. Environmental issues like pollution can be reduced to a great extent. Like burning a fossil fuel means there will be emission of gases like carbon dioxide, carbon monoxide, sulfur dioxide, all these things. But when we use more and more renewable energy resources, which by using power electronic converters, like renewable energy, solar energy, there is no pollution, there is no emission of greenhouse gases, nothing, wind energy. So all these things, electric vehicles are being promoted. So all these things need a converter. Power electronic converter is the heart of all these things. So that's why we need power electronic converter, there's an energy scenario we can say, or the environmental issue also you can explain. So what exactly is a power electronic system? To convert electrical energy from one form to another. So I have explained power and electronics separately. So one is concerned about efficiency, one is concerned about distortion. So power electronic converters, all together, it is highly efficient, it is highly available, highly reliable, lowest cost, smaller size, least weight. So you might have seen BJT, or you might have seen a MOSFET. You might have seen BJT, right? Bipolar junction. How small it is. You might have seen a capacitor. So capacitor, inductor, all these things are constitute a power electronic converter. So that's very least weight, low cost also. All these things. Then we can talk about the applications of power electronics. So like it can be used as a DC power supply. In the UPS, you might be having UPS at your home. Uninterrupted power supply, then HVDC, heating, cooling, welding, then drive applications like in electric vehicle, the control panel will have a converter, electric trains will have air conditioning system, pumps, compressor, conveyor belt, everything. There is no place where we cannot use a power electronic system. Like electric train, if you are explaining, like that I will explain when I talk about different types of converters. Okay, so this is basically the application. So now we have seen why we need power electronics. What are the applications? Okay, this is one example, like practical figure which I can show you. Like this is the PV system. This is the PV system, and this is the PV system, photovoltaic solar panel. Like here the converter will be there, and then this is the DC, same system, like power electronic converters, AC. Then that can be given to the grid. So from the sun, by using the sunlight, DC source PV will be there, and that PV like inverter. Everybody might be familiar with these things. You have an inverter at home, right? So DC is converted to AC, and then again we can give that to the grid, and we can take money from through that also. So all these things require the efficient use of power electronic converters. So all these things require power electronics. This is one example. Okay, then I was talking about DC power supply, right? So DC power supply you might have done in your school days itself, like AC, diode rectifier. So this diode rectifier is actually a converter, AC to DC converter. Then filter is there. Then DC to DC converter. Like DC to DC converter, you will study different types. So this basically the DC power supply also controls the converter. So if you are using a converter, means we should control it. How much output we need, like what we are giving here, how much of that we need it as the output, that will be controlled by using a controller. That is by using. So this feedback circuit I have shown you in the previous slide, right? Yeah, that is basically just to make you familiar with the things, just to connect you from what you have studied in the previous semesters with this topic, power electronics. I'm showing all these slides. Okay, and this is basically the drive application, air conditioning system, how it is happening. Here also you can see that we have a power electronic converter. Then based on the temperature and humidity system, we are sensing it and then giving to the controller. Then we have a reference value, which is the desired temperature and desired humidity. So if the output that is being fed back is different from the desired temperature or desired humidity, we can say that it will be an error. And that error again will be adjusted by the power electronic converter. So in that way, air conditioning system driver is so we have the power electronic converter application here, right? So then power electronics is also used in many interdisciplinary applications, whichever area we go, like soft computing, solid state, circuit theory, control theory, signal processing, electronics, electromagnetics. So power electronics can be mixed with all these areas, and then we can make it more efficient, more reliable, all these things. Power electronics is involved everywhere. These are the interdisciplinary applications. Now in your syllabus, if you see, you might have seen it is a like difference between power electronics and signal electronics. Already I explained. One more time I will explain, because in the introduction I explained. So electronics in general sense refers to the processing of information, be it amplifier, oscillator, filter. You have studied all these things in analog electronics, right? Like I have given you, I have drawn and explained it. A mic output would be a voltage varying with time. So the voltage signal represents a person's voice, music, etc. So you have studied signals and system, right? So interest lies in processing the signal rather than the power supply. So without any distortion, the signal should reach the speaker, right? So whereas in power electronics, the focus is more on efficient utilization of electric power. So power plus electronics, not just electronics. The system designed will be converters, like we have the rectifier, inverter, buck boost. So it is a type of converter. It's a chopper. You study all these things, which focus on driving a required load. So you have seen here how the required load is being driven here in an AC, in an air conditioning system. There is no information embedded with as in audio or video signals. So there is no embedded information is not there in power electronics. So the main difference between power electronics devices and analog devices are operating voltage and current. In other words, power. So power electronic devices means operated at high voltage. Electronics simply was a low power. So power electronics, power plus electronics means it will be at high voltage, that is greater than 30 volt to 30 kilovolt, and at high current, that is greater than 2 ampere to 10 kiloampere. They are used in power transmission, distribution, inverter, industrial converters, etc. So basically we have power diodes, MOSFET, IGBT. If you have seen the syllabus, these are all coming in the next lectures, SCR, etc. But analog devices deals with the low voltage and current. Another word, low power device, that is the operating voltage, like between zero, very low voltage, like maximum 30 volts. You know what, in the analog electronics lab, the maximum supply that we use is 30 volt, like 30 volt DC, like CRO when you are using all these things, you know, remember. Then BJT, LED, all these things you have studied and you have done the lab also. So now we are going to study about power electronics, which has high power application. So the switches that we are using there will be the components that we need to be familiar. There are MOSFET, IGBT, SCR, all these things, right? So this actually explains like power electronic semiconductor devices, switches. So there are different types of switches there. So before going to this portion, I will explain to you like what exactly will be. So I'm winding up the introductory section. So power converters are divided into 4 types based on input and output. So you have seen what is a power converter, right? And the first one will be something you have already studied, that is rectifiers. Rectifiers means AC to DC converter. So AC to DC power electronic converter is the rectifier. And second one, DC to DC converter. So we call them chopper. So we'll study in detail. Second module you will study. Then third one is AC to AC converter. Like one sinusoidal signal is converted to another sinusoidal signal. So again, this AC to AC converter is again of 2 types. AC voltage regulator, and then we have the cycloconverters. And the 4th type is DC to AC converter, which is the inverter. So basically in this module, up to the 4th module, you will be studying about all these different types of converters. AC to DC, DC to DC, then AC to AC, then DC to AC, and finally you're studying about drives. We'll see, last module is basically about drives. So this is actually the entire coursework of power electronics. So hope whatever we have discussed is clear for you. So we have basically talked about difference between power and power electronics and analog electronics. So what is power electronics? So why we are studying, what is a power electronic converter? Then what are the applications? Then what are the different types? And then we have discussed about our syllabus and all. So everything is clear for you. So in the next class, we will be seeing what is a power diode, then switching characteristic. So as per the KTU syllabus, we will be going. So thank you.